Without delay, I would like to welcome you all to the first session of the day on the track Electrical Engineering. Before moving on into the session, let me introduce you all to our speaker of the session, Dr. Abraham G. Mathew, Professor NIT Calicut. He is currently specializing in instrumentation and control. He has a PhD thesis on the studies of parameter estimation of continuous time system using Hermite polynomials from the Department of Electrical Engineering, Indian Institute of Technology, Delhi, 1995. This is indeed our pleasure to have you here, sir. On behalf of IEEE MSS, cordially welcome you all to the session. Thank you.
Thank you. Hello.
Yes, sir, you're audible.
Yeah, I would like to share the screen.
Yes, sir.
Can I get that screen?
Sabik, share screen permission enable ചെയ്തിട്ടില്ല. You can click on share screen, sir.
Okay, let me. Okay. Can you see now?
Yes, sir. It is coming, sir. Yes.
It has come, sir. Just put it in slide mode.
Yeah, sure. So, thank you for the introduction. I will begin with the talk on career prospects and professional development in engineering, electrical engineering. My focus will be specifically electrical engineering and also the possibility of escalating or migrating to other disciplines once electrical engineering degree program is completed. So, as Dr. Madhu had introduced, there are different levels of training in the engineering field. So one is towards more skills and one is towards more knowledge. So the trade certificate is the lower level where the skill is given more emphasis, and the diploma is the next level where little more emphasis is there for the knowledge, and then comes the graduate degree, which is somewhat in the middle of the engineering education. And then comes the postgraduate degree, and then last one is the PhD degree. So these are the 5 levels with which the engineering education happens, and personnel who are trained in any of these 5 sectors of education are needed by the society and industry. So we cannot say that one is lower or one is higher. Personnel are needed from all these sectors. There are slight differences in the job profile and also the remuneration profile. But if you consider the graduate engineer, I will begin from there. For a graduate engineer, the employment market is divided into 4 sectors. One is industry, which is a major stakeholder in the employment of engineers. And the second is teaching. And the third one is government job. And the fourth one is the defense job. I will go a little more detail into all the 4. So when it comes to in the industry, if we consider the highest paid job in an industry for an engineer is a PhD engineer or a research engineer who is doing a very specialized research in the area of developing a new technology for the future requirement. So the salary will be higher, and of course the opportunities would be very limited, and it will be opened only for very specialized hands who have proven their capability in innovations. And the second level is PG engineer, who is to do research in converting technology into engineering. And opportunities are limited, but salary is higher. And the graduate engineer is the middle level, who will be doing the entry level management and also the engineering designs. Manufacturing, they will be planning for the operations, they will be scheduling the maintenance. All managerial level and engineering level jobs done by the graduate engineers. So their salary is in the middle level, but higher comparatively, and the opportunities are more compared to the PG engineer or the PhD engineer. And then comes the diploma engineer, who will be working with the graduate engineer to implement the designs into product and supervise the manufacturing operations and maintenance. Their salary will be at the medium level. And then we have the show floor level engineering certificate holders, who will be actually doing the work by hand to convert the design into the product using the machinery or the processes in the chemical engineering, as if it's consider the chemical engineering. Now, coming to the teaching, in the teaching job, PhD engineer or PG engineer go into the teaching, while we will have the level of scientific officer and research assistant, who can be assisting the professors in the research, or who can be helping them in the consultancy work. So the qualification needed for the scientific officer or the research associate is postgraduate degree or BTech or the diploma, depends on the requirement. And the trade certificate holder will be finding their place in the laboratories as supporting staff or the demonstrators. And in the case of defense, in the government, as like the PhD, what you can say, the health department or water authority, PWD, those departments, or you can say the National Airport Authority, Highway Authority of India, such places, PhD engineer will not have much role as an engineer, but the PG engineers, graduate engineer, diploma engineers are all employed as engineers, starting from the assistant engineer level to the chief engineer level. And then the trade certificate holder will be working as the mechanic, operator, and helper. Here also the salary component, if you look at the salary profile, it will be rising in the direction of the higher education. And now coming to the defense, the PhD engineer or the PG engineer will go into teaching in the academy, defense academies. Then the graduate engineer and the PG engineer or even the diploma engineer will work as commissioned engineers in the defense in the three, can say Air Force, Navy, and Army. All the three divisions of the defense has opportunities for engineers, and they recruit BTech engineers. There are engineers who are studying in the defense academy, but they also take engineers from outside. And then the defense also, there are opportunities in the academies as well as to work with the defense system outside in the field to support the equipment maintenance and operations. Now, electrical engineers also will find opportunities. In the defense, electrical engineers and mechanical engineers will find more opportunities compared to other disciplines. And now coming to electrical engineering, just to give you a brief definition, electrical engineering deals with the study, design, and application of equipment, devices, and systems which use electricity, electronics, and electromagnetism. So electromagnetism will come into energy conversions, electronics will come into the electronic circuits, and electricity is the energy behind the driving of all these systems. Now, the mission of engineering is basically to improve the quality and standard of life of the humanity. So if that is kept in mind, how electricity is affecting the life of the common man. The snapshots shown below are taken from the internet showing the nighttime scenery of big cities starting from Bombay, Sydney, London, Toronto, and Singapore. So here you can see that the night time is bright and live because of the electricity. In the past, when electricity was not there, the situation was not so. Everybody will have to return to their place of residence at the onset of the night. But now we are able to keep the life going for 24 hours because of electricity. Now, for example, if we consider the blackout in New York, in the night, the life was very horrible because there were total darkness, only moonlight was available. But when it comes with the electricity, you can see brightness in the night. So it has become so important that the per head consumption or per capita consumption of electricity is an indicator of the socio-economic development of the country. So places like US or Canada or Australia, where the per capita, even China, the per capita consumption is very, very high compared to that of India. And we can see that the life standard, the so-called modern life standard is high there. Now, coming to the electrical engineer as a personnel, trained personnel, an electrical engineer should have a balanced mix of knowledge, skill, and attitude. This is necessary for all the disciplines of engineering, but I here put emphasis on electrical engineers. So there is a mix of skill, knowledge, and attitude that is important. I will explain it further. The knowledge means it's the cognitive knowledge what resides in the brain. We should have the knowledge in mathematics, computing science, material science, network analysis, electromagnetism, design, aesthetics. All these are cognitive abilities. That should be very strong. And then one should have the analytical skills, design skills, problem solving skills, programming skills, computer design skills, simulation skills, project management skills. These are needed for the engineers. And attitude is that an engineer should be able to work in a team. He should be able to work with other people. He should learn continuously in the life. And also he should be ready to work hard to go an extra mile if the situation is demanding so. So all the three domains in the expertise, knowledge, skill, and attitude should be properly balanced, and then that will be making an engineer very successful. Now, problem solving skill means it is not the mathematical problem solving. It is the ability to understand the total solution and ability to coordinate the people and ability to divide the task and ability to integrate the solution and ability to review the situation and improve. These are the characteristics needed for an engineer, especially at the degree level or graduate level or above. One should be able to put our knowledge together, our people together, and identify solutions, devise the solution and put the solution into a product form or a service form. Now, when it comes to the areas of electrical engineering, we have the electricity generation, transmission, distribution, and electric traction, electric vehicles. All these are specializations in its own way. Though they are sub-branches or the subtopics in electrical engineering, they are specialized domains in the practice in the real world. So in all that field, there are 5 levels. Again, the technology R&D where the requirement is the person has fast learning, hard-working nature, and good communication. And engineering R&D means converting technology into product. So they should also be intelligent, fast learning, hard-working, and they should be a good leader because they have to work with other people. Then the operations means there again, person should understand, devise the schemes, manage it, manage the people, and then the maintenance. Again, the system will have to continue the operation. So the maintenance should also be planned. So he should have communication with all the people. And the customer relation means reaching out to the public. These are normal jobs in the industrial context. And the knowledge level will be going higher from the lower level to the R&D level. So if a person is interested in research and development, he should be concentrating on very specialized learning, and also the person should be having the characteristic of learning very fast and working beyond the time. Now, for example, if you see a generator, this is a big generator where one person can walk through. So the diameter will be of the order of 7 feet. So such a big generator generating some 1000 megawatt is to be made and assembled, and that should be put into operations. So the idea starts from the level of the requirement of generating such a big quantity of electricity, but it finally gets converted into a generator. So it is the culmination of the effort of many people, starting from the research and development. Now, coming to the other opportunities which are available now for electrical engineers, we have the emerging requirement of electric vehicles, then electric trains, then the thermal power plant, the wind farms, the solar power systems, or the hydroelectric plant. These are the places where electrical engineers will have an important stake in its, first of all, making them and then operating them. Now, coming to another one, like making life possible outside the land. If you see a cruise ship accommodating more than 1000 or 2000 people for many days, it should have all the living setup. And there's such a big establishment of a cruise ship is possible because we can have onboard electricity generation systems, and we can have engineers to run it. So there is an engineering behind all these designs as well. Now, coming to the new developments in aircraft we know the technology of aircraft started some 80 years back, but now people are looking at making electric aircraft. Some, you can say, some success was there in propelling or flying one aircraft with battery on board, but now, similar to the hybridization of the land vehicle, research is going on to hybridize aircraft. So naturally, the second energy for hybridizing is electricity. First energy, if it is fuel, the aviation turbine fuel or ATF, the second fuel will be naturally electricity. So this is another area coming up for electrical engineers. Now, there is another sector in electrical engineering called the transmission and distribution systems, where the multitude of equipments required of various capacities are built and managed by the engineers. Now, coming to the mass rapid transportation systems, you can see that the electricity is the main propelling force in electric traction. And where there are various companies like ABB or Siemens and BHEL who are working in developing the systems, and Indian Railway and other railways of other countries are the customers who use electric traction. And then there is another segment. When the building becomes higher and higher, the climate control and safety in the building become important. So the electricity becomes a very important energy used in that building. So the energy management or the building management itself is facilitated because of the very nature of electricity. We can use it, we can store it in very small or big quantities now, and also it can be extended to different types of devices. So the electricity continues to be the versatile form of energy, and electrical engineering is the propelling force of all engineering activities and systems in some form or other. Now there is an apprehension. Recently there is a drop in enrollment in electrical engineering courses. Why? Because people say that there is no takers for electrical engineers. So the reason is not that electrical engineers are not needed. Electrical engineers are much wanted across the world, but recently the emergence of specialized branches like biomedical engineering, applied electronics, instrumentation, avionics, or robotics have taken away some of the jobs which were earlier available for electrical engineers. And in some sectors, the diploma engineers are used to substitute the degree engineers. So that way the diploma engineers are available in more in numbers. So naturally there is a loss of opportunity for the graduate. But if we look at the scenario across the world, electrical engineers have very high potential, and that you can see why. The knowledge in the various topics of power system, machines, network, signal processing, and a bit of mechanical engineering make the domain knowledge of electrical engineers more universal and flat. They can migrate or they can work with any group of people, and they can tell the problems of the modern systems because all are driven by electricity. Then the design skills and the social perspective of electricity and the multidisciplinary attitude is of the electrical engineers become useful, and the scientific knowledge in various topics provide a basis for migration and specialization to other fields. And electrical engineering is the power behind all modern activities. And there is a fifth dimension for any engineer. There is a fifth dimension, especially for electrical and mechanical engineers. That fifth dimension is to contribute something to the social development through self-employment. So you can be your own boss. Now today minister, our prime minister is giving a lot of emphasis for Atmanirbhar Bharat. Atmanirbhar means self-reliance. So we can be self-reliant only if we produce insight and use insight or consume insight. Now, just a few slides on giving you some hints on migrating to other branches. Suppose after graduation, if a person wants to do something in some other field, not in electrical engineering, he can migrate to the other field. Suppose you want to go to electronics and information technology, you add the courses or the credit in microelectronics, communication and signal processing, and you can go for postgraduate degree in or PhD degree in electronics and communication. And if you want to go to artificial intelligence or automations, go through the direction of control and instrumentation, and you can land up with robotics, automation, and artificial intelligence. And if you want to do higher studies in computer science and engineering, take courses on data structures, algorithms, systems and software engineering or database management, and you can reach computer science. So in the world, if you look out, the professional development is not limited by anything but your imagination. So there is only sky is the limit if you are ready to fly. So I will be concluding here by wishing you all the best. Jai Hind. Thank you.
Thank you, sir. So I think we have some questions here. So can we please look into that?
Thank you, sir.
Yeah, sure.
So we already have some questions from participants. So one of the question, Muhammad Shivi have asked, what are the scopes in abroad, especially in European countries?
Pardon?
So what are the scope for electrical engineering in abroad, especially in European countries?
Yes, in Europe, the recent development was that Europe had become one, and they have integrated their grid also, and also they are giving more emphasis for renewable energy. So when it comes to renewable energy like solar or wind, the conversion from the natural form of energy, that is solar or wind, to electricity needs a conversion. And there is a need for storage to deal with the uncertainty in the source side. So a lot of research is going on in Europe to use the modern technology, and the renewable source is also expanding. So that because they want to reduce the carbon footprint in Europe.
Thank you, sir. There are multiple questions related to defense recruitment, like which branch is good to join defense, some around that.
Yeah, in defense, mainly it is for the, there are two requirements, two roles. One is to develop the specifications of the weapon systems and the weapon carriers. And the second is for maintaining them so that the weapons can be used at any point in time. So to my knowledge, electronics engineers, electrical engineers, and mechanical engineers are dominating in that defense sector. But computer now, because of the emphasis of computers and computing in cyber security and things like that, there are opportunities for computer engineers also there. But chemical engineers, civil engineers find their position in finding solutions for connectivity, for constructing bridges or laying bridges, but they are confined to research and development. But the field is mostly open for electronics, electrical, and mechanical engineers. And the specific positions are available for computer engineers.
There is one question that is comparing with electronics and communication. We have a separate session next, but still there is a question from a few of the participants whether EEE or ECE is difficult to study and which is better for girls.
No, no, there is nothing difficult for girls, to be very frank. It's all limited by the imaginations and readiness to work. You can see that electrical engineers are working with the both male and female. They are working with all the sectors in the defense, in the industry, and also in teaching. Teaching now the proportion is increasing. Now, when it comes to electronics and electrical engineering, both give a lot of emphasis for higher order mathematics. That is the point. So the mathematics is having a greater importance in communications, in electromagnetics, in electrical systems analysis and modeling. So if the person has a good flair of knowledge in mathematics and good attitude to apply mathematics, both electrical and electronics or electronics and communication, both branches would be equally interesting and equally useful.
Thank you, sir. Sir, you mentioned about aeronautical engineering in between. So which branch will be good as a graduate engineering course to do higher education in aeronautics engineering, aeronautics and aerospace?
If a person is very much interested in aeronautics or aerospace engineering, better to join the branch of aerospace. IIT Madras and IIT Bombay and IIT Kanpur, they have aerospace engineering, and some